Let's take a look at this one. One last problem. I guess I should have made this three different nearpods. So we have the limit as x approaches 0 of secant x minus 1 over x times secant x. We could try multiplying by the conjugate, but let's try something else. Let's replace secant x with 1 over cosine x. So that can be something you're thinking of, replacing with a reciprocal, because then you can get a fraction. Now, why would I want to do that as opposed to plugging in? Well, if I secant 0, that's 1. 1 minus 1, that's just going to 0. And if I multiply anything by 0, this is going to go to 0. So this is an indeterminate limit. So we can't just use direct substitution. We would have to use some type of algebraic manipulation. And one that might work is rewriting this as a fraction. So we have the limit as x approaches 0. We'll change secant x to 1 over cosine x minus 1 all over. And then we have x times 1 over cosine x. All right, so let's make this one fraction. I'm going to rewrite as 1 fraction. All right, so that's going to give us the limit as x approaches 0. And how do I rewrite that as 1 fraction? Well, why don't we change 1 is this, I can replace that with cosine x over cosine x, right? So I've got 1 over cosine x minus cosine x over cosine x all over, now I'm going to write that as x over cosine x. All right, so now let's combine our fractions. So we have the limit as x approaches 0. So that's going to be 1 minus cosine x over cosine x times, so if I'm dividing by x over cosine x, it's the same as multiplying by the reciprocal, cosine x over x. Now I've got a product. So long as I don't try and split up that 1 minus cosine x, it's a product, right? I've got the 1 minus cosine x and the cosine x in the numerator, the cosine x and the x in the denominator. It doesn't matter if I flip them. So the limit as x approaches 0, 1 minus cosine x over x times cosine x over cosine x. Well, that's just going to be 1. So I've got, I need a smidge more space. I'll just do that. So we have, and I'll write down here, equals the limit as x approaches 0. I've got 1 minus cosine x over x. That's just times 1. Well, that's just, I got the limit as x approaches 0 of 1 minus cosine x over x. Have we seen that somewhere? Look at that. The limit as x approaches 0 of 1 minus cosine x over x. And that's equal to 0. I thought I had the 0 in there. Equals 0. And look, we have a 1 minus cosine x over x. We can use that rule. So this one does not have a whole lot of applications, because if it's not 1 minus cosine x over x, you can't use this rule. So it doesn't have all the variations like the sine has. You go start squaring things, you're going to mess the whole thing up. So a little bit of a limited use, but if you happen to have this particular limit or something that you could rewrite to make that particular limit, you can use this cosine rule. All right, so you've learned, the most important rule is that sine rule, and you've learned all sorts of ways of rewriting, and now you can do problems like these. Thanks for watching. Bye for now.